Closely related to the problem of counting permutations of a word with distinct letters is counting rearrangements of words having repeated letters. So for example, how many rearrangements of the word Mississippi, Mississippi, are there? So one thing we might guess is we can count the letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 factorial. But this isn't right. This is overcounting because if we think about, if we permute this in all possible ways and then just switch the two i's here, ISSI, or switch the two p's or switch any two s's, those are going to be different permutations of the 11 letters that actually give us exactly the same rearrangement. So there's a bunch of things that we can do to that word, different permutations of the 11 letters that give us exactly the same rearrangement. So we're overcounting by some factor if we say 11 factorial. And coming up with the exact number is actually pretty easy. And the rule is, if we have, let's say, A1, A2, a bunch of numbers, let's say k of them, that add up to n. So these are how many ones, how many twos, etc. are in a word with letters 1 through k. Then the number of rearrangements of the word having A1 ones and A2 twos, etc. up to AKKs is, so we're assuming there's n letters altogether. N factorial is our guess because there's that many permutations of this many distinct symbols. But then we have to correct for overcounting. Whenever there's a repeated symbol, all A1 factorial permutations of the ones don't make any difference. So we'll divide by that. And then all A2 factorial permutations of the twos don't make any difference. So we have to divide by that. That's another reason we'd be overcounting, etc. We do this for all the letters, all the way up to AK factorial. And then this denominator is exactly the factor by which we're overcounting when we say n factorial. We're correcting for all of the different permutations of equal letters that don't give us new rearrangements. Alright, so let's go back to our question. How many rearrangements of the word Mississippi are there? Well, we need to figure out what letters are repeated and how many times each one of them is repeated. So we have 11 letters. M appears once. I appears 1, 2, 3, 4 times. S appears 4 times. P appears twice, and I think that's all the letters. So the answer is 11 factorial divided by 1 factorial, 4 factorial, 4 factorial, 2 factorial. And of course, 1 factorial is just 1, so maybe it's not even necessary to write that. So this is how many there are. Now I did some cancellation in the numerator and denominator. I didn't get a simpler expression. I mean, I got a number, but it just doesn't look like anything special. I got 2,475. But I think I would rather look at this expression, because when I see this fraction, I think of 11 different letters permuted in all possible ways, and I can see the overcounting factors taken care of here. There's some letter that's there 4 times, another letter is there 4 times, another letter is there twice. So I actually prefer this expression here. The end.